Is there a status report from the work of, I believe, glucosepane breaking?
Okay, yeah, I can spend a couple of minutes on that. So yes, absolutely there is. So the last published information on that, I'm sure this is the reason for the question, was 18 months ago when we had this very important breakthrough paper in Science magazine showing that we could now synthesize glucosepane in a test tube, which means that we can now make grams of the stuff for almost no money, in contrast to the previous situation where the only way to isolate it was to break down old collagen, basically. And doing that, it's extremely laborious and expensive, and it only gives trace quantities of the stuff. This is enormously important as an enabling breakthrough, because what it allows is for us to do all the obvious things that require a certain amount of material, such as raising antibodies to the stuff or identifying bacteria that can break it down, things like that. And so what's been happening over the past 18 months is precisely that. The group at Yale have been banging away really well on this. We've been able to continue funding them. And actually, David Spiegel, the professor from Yale, was actually visiting the Bay Area just yesterday, so we had a good update. The short story is that on the antibody side, that's been done. There's now a good antibody, and actually with some funding that we recently received from one of the founders of Oculus, we were able to supplement the funding of that group to the extent of being able to create a monoclonal antibody. That's very important for scaling, because it means that you can create, because it's molecularly precise and identified, it means you can make as much of it as you like. And of course, that's very important for determining how well something is working. If you have a drug, for example, or an enzyme that's supposed to break this stuff down, you want to be able to measure the result, and antibodies are the way to do that. And in terms of actually finding things to break it down, we're mainly focused right now on the enzymatic approach, identifying bacterial enzymes that are able to do this. And that whole way of doing things has evolved quite a lot from the situation we were in more than 10 years ago, when we were applying this approach to atherosclerosis and macular degeneration. Of course, when we did that, we had some good successes, and the result has been now those projects spinning out into companies, including ICOR, which is run by Kelsey Moody, that worked on our macular degeneration work. But now how this is done is a little bit more sophisticated. Rather than just getting soil samples from them from all over the world and just sifting them, essentially, and finding bacteria that can do this or that, what you do instead is you identify DNA from the environment. You don't even need to know what species the DNA came from. And you essentially insert random chunks of DNA into regular culturable bacteria like E. coli, modified in such a way that they need this particular function in order to survive. So, for example, you break some pathway that the bacteria naturally have that would synthesize some particular amino acid. And long and short of it is that's also going very well. The results are a bit preliminary still. I don't want to say too much because, that's the nature of science. We really want to be sure. But we're very excited right now at the rate that this is going, and totally watch this space. We will be publicizing things in our newsletter, of course, and on the website as soon as we possibly can, as soon as things get to a point where we're really sure that the progress is real.